Okay. So what we're going to be looking at today is treating wastewater, and there's two main things that we are going to do. First thing we're going to do is we're going to recap some of our previous learning. So some of the stuff that we've learned about previously in this topic, chapter 14, the Earth's resources. And then afterwards, we're going to look at the process needed to treat wastewater. Okay. So as mentioned, make sure your cameras and your mics are off, guys. If you want to ask a question, just write it in the comment box. And remember, if you're not able to type in the comment box, just send it to me privately, and I will see that, and I will be able to answer you there. And as I mentioned, also this PowerPoint will be uploaded afterwards, so don't worry if you can't write anything down or all of the information down, because you will be able to have it afterwards. Okay, but it will be good to have pen and paper to hand, because there are going to be a couple of quizzes that I'm going to ask you some questions on. Okay, so we're going to start with a short recap, okay, in a form of a multiple choice quiz. So what I'd like for you to do, obviously there's 4 here, some of them only have 3, but whatever you think your answer is, just type it into the box and then we'll just go through it like that. So the first question is, which is an example of a renewable resource? So 1, crude oil, 2, limestone, 3, metal ores, 4, biofuel crops. You don't need to write the whole word, you can just type in the number if you want to. Just going to give 10 seconds to see as many answers as possible. Okay, good. A lot of people are saying biofuel crops. Number 4, good. Okay, so this is an example of a renewable resource. Something is renewable when it will not be depleted over time, either because it can be replaced or because there's an infinite amount of it. So, a question that I've asked here, what word can be used to describe the other resources? So write that in the chat. What word can be used to describe the other resources? Crude oil, limestone, metal ores. What word can be used to describe the other resources? Okay, I'm seeing a couple of different answers. So when we're talking in chemistry, we're more likely to describe these as finite resources, okay? Finite because they can be depleted. Crude oil is going to take a long time to be able to recover the amounts that we have today if we finish it all by 2050. It takes millions of years for crude oil to be formed, so it will be depleted before it can be back up to its normal levels again. You can use non-renewable, but we more talk about that when we're talking in physics, when we're talking about energy sources, different things like that. In chemistry, we more define them as finite resources or renewable resources. Okay, right, or geography, yeah, or geography for those of you that do geography. Okay, next question. What term is used to describe water that is safe for humans to drink? I'm literally going to give you 5 seconds for that. 1, 2, or 3. Or A, B, or C, whatever. Excellent. A lot of people are saying potable. Okay, remember potable, or as Free Science Lesson Guy calls it, potable. Either way, as long as you write it and spell it correctly, you will get the mark. Okay, so potable water, water that is safe to drink. Okay, so in the chat box, can you answer this question? How is potable water different from or to pure water? What is the difference between potable water and pure water? Okay, I'm seeing lots and lots of different answers. I'm seeing potable still has minerals. Potable water has minerals and salts in it. It still has some dissolved minerals. Pure has no minerals. Pure has nothing else in it. Pure has dissolved impurities. Potable water has minerals and salts in it. Pure doesn't. Lots and lots of answers here. Okay, so pure water has no dissolved substances. Okay, so pure water is literally just H2O, nothing else inside of it. However, potable water is water, but it still has low levels of salts, mainly salts such as sodium chloride, for example. However, microbes, different things like that, most of those have been removed in order for it to be safe to drink. So both pure water and potable water are safe to drink, but pure water is the only one that has no dissolved substances. Well done. A lot of people getting that correct. So we'll move on to the next question. What is the term used to describe the conversion of salty water to potable water? 1, 2, 3, or 4. Desalination, sterilization, sedimentation, or osmosis? Okay, I'm seeing quite a few correct answers. Good. Okay. Okay, so it is desalination. Yes, desalination. Desalination, removing salt from water and it will turn into potable water. Next question. Why is it essential that humans alive on Earth today do not use up all of the Earth's resources? So there's three choices there. So read each of the three and make your choice. Why is it essential that humans alive on Earth today do not use up all of the Earth's resources? Okay, right. So most people are saying one, which is correct. So that future generations of humans can meet their own needs. Okay. And this is another way of saying that something is sustainable. Okay. To make sure that the way that we are using all of the resources today, future generations are able to use those resources at the same way. So you'll remember from lessons, I always talk about crude oil, that crude oil is running out. So, when you guys are in your 40s and 50s, you guys won't be able to use crude oil uh, resources such as petrol, diesel for your cars, which means it's not sustainable. You have to think of alternatives, things that we've talked about, such as hydrogen fuel cells, different things like that. Well done, good. Which of the following is not a method used to kill microbes during water purification in the UK? Chlorine, boiling, or UV light? Which of the following is not a method used to kill microbes during water purification in the UK? A lot of people saying 3, which is UV light. And that is incorrect, guys. Okay. Using chlorine and UV light is the ways that we are able to kill microbes, okay? Boiling, why do you think we cannot use boiling? Imagine all the water that everybody in the UK uses. Think of the amount of water that you've used today, okay? Why do you think it's not a good idea to use boiling to kill microbes in the UK? Good, I'm seeing some correct answers. So we can't do it large scale. Lots of energy will be needed for that. Lots of energy. It's going to be expensive. It needs fuel. Okay, it will need a lot of electricity to heat it. So for that reason, we don't use boiling to kill microbes. We either use chlorine or we use UV, which is ultraviolet. And we're going to talk about that further on today. Okay, so what word can be used to describe using chlorine or UV to kill microbes? What word is that? I think we've met this word already today. What word can be used to describe using chlorine or UV to kill microbes? Okay, excellent, good. So I wrote sterilizing, but yet sterilizing, sterilization, fantastic. Okay, good, well done. Which of the following substances is removed by filtration? So when we are trying to produce potable water from reservoirs, lakes, etc., which of the following substance is removed by filtration? Well done. Excellent. Good. As you can all see from Yasin's bright green and purple 2, the answer is insoluble particles. Okay. Insoluble means that they cannot dissolve, so they can be removed by filtration. Excellent. Okay, so in countries with few sources of fresh water, desalination is sometimes used to convert salty water into potable water. Which statement about desalination is correct? I'll give you guys time to read that. Okay, so people are putting 2, people are putting 1, a big red 2, people are putting zwei. This is in German, guys. Okay, so the correct answer is 1. I saw one person put 1. Who was that one person? Let's give them a Shout out. Alina, well done, Alina. Okay, so reverse osmosis is one of the methods that we can use to carry out desalination. It is a simple process involving passing water through membranes. However, it's not heated. Okay, it's not heated. So because it's not heated, it actually uses a lot less energy than distillation would have to use. Okay, so the answer is the first one. Reverse osmosis uses less energy than distillation. And the reason for that is the fact that we do not have to use any heating during reverse osmosis. So that brings down the energy costs, etc., etc. Okay, last question, guys. Last question. The apparatus shown is used to obtain pure water from salty water. What process occurs in the tube labeled X? Sublimation, boiling, condensation, or melting? Let's have your answers. Okay, good. Lots of people putting 3, which is condensation. Okay, so what is this whole process called, guys? What is this whole process called? This is a required practical. We did this in paper 1. What is this whole process called? Okay, excellent, good. Okay, so this is distillation, or you can call it simple distillation, because there's another type of distillation as well. What's the other type of distillation, guys? So we've got simple distillation, which is this. What's the other type of distillation? Excellent, good. Fractional distillation, which is different. Oh gosh, I'm just remembering all those organic lessons that you guys enjoyed when we're learning everything, polymers, etc., etc. Okay, good. So we've now recapped our previous learning. Okay. Daniel, you guys just can't help yourselves. Okay, so we have now recapped what we've looked at previously, and what we're going to look at now is what we're going to look at now is the next lesson, or the next topic, which is treating wastewater. Okay, so when we've been talking about treating water before, we've been talking about water sources such as from reservoirs, lakes, rivers, and we also talked about in countries where they don't have those, where they would have to use seawater. But what we are talking about now is treating wastewater. Okay, so the wastewater that we're talking about is the wastewater from homes, from industry, and from agriculture. Okay, and before it's released back into the environment, into rivers, lakes, reservoirs, etc., it must be treated. Why does this have to happen? Because they will contain pollutants. And some examples of these pollutants, if we're talking about human waste, it contains harmful bacteria, high levels of nitrogen compounds, which can harm aquatic ecosystems. I'm not sure if in biology you guys have reached the topic of eutrophication. If you, maybe those of you that do geography, you have, but nitrogen can really affect organisms that live in aquatic ecosystems such as rivers, lakes, and different things like that. So human waste, so from when you flush your toilet, from when you run the sink down, from the bath, etc., needs to be treated, okay, because of those different things. Industrial waste as well also needs to be treated because it has harmful chemicals such as toxic metal compounds, such as lead and different things like that. And that can lead to bioaccumulation in animals. The same thing as we mentioned before, that can happen with organisms that live in water as well. So we need to be able to treat industrial waste. Oh, pardon me. We also need to be able to treat industrial waste in the same way. And finally, we also need to treat agricultural waste. And agriculture is things to do with farming. Okay, so anytime you see the word agriculture, agricultural, that's to do with farming. So in farming, they use a lot of fertilizers, pesticides, herbicides, insecticides as well, which can disrupt sensitive ecosystems. So if you are spraying pesticides on your wheat crops, for example, that's good for your wheat crops because your wheat will not be disturbed by insects, but the insects themselves will be harmed. Okay, so we need to ensure that whatever type of wastewater we have, we are able to treat it so that it's ready to go back into the environment and not have harmful consequences. So what are the steps for sewage treatment? Okay, so I'm going to go through this slowly and then we're going to look more at the diagram to bring this all together. So the first step is screening. Okay, the first step is screening, and this is where you pass the sewage through a metal grid to remove solid objects. Okay, and we can see that in the diagram. The sewage arrives and it goes through screening. So any large particles are able to pass through, are not able to pass through, so we're able to remove the solid objects. The second step is something called sedimentation, okay? And what this does is any tiny particles, because remember through the grids, that's only going to be larger particles. Some of the small particles are still going to be able to go through. So the tiny particles settle out from the water, so that will settle to the bottom, and that will produce something called a sludge, a sewage sludge. And the water on top, we call it the effluent. Okay, so we've got two things here. We've got the sludge, which contains the tiny particles. So you can imagine what type of tiny particles will come from human waste, household waste, industrial waste, and agricultural waste. And at the top will be the water, which we call the effluent. Does anyone have any questions so far? Type yes or no if you have any questions at this stage. You might have any questions about the sludge or the effluent. 9. This is turning to a German lesson, guys. No, no questions. If you do have a question, please do not hesitate to ask. Okay, no questions. So the next stage is the sewage sludge is digested anaerobically. What does anaerobic mean? Type it in the box, guys. It's digested anaerobically by bacteria. Okay, and that's important that you remember that it's anaerobic. What do we mean by anaerobic? Yes, and Jamal, I will delete you if you're not careful, please. Good, well done, without oxygen. Okay, so sewage sludge is digested without oxygen. That is very, very key because the effluent is treated with aerobic bacteria to reduce the volume of solid waste. So the sewage sludge is digested anaerobically. by bacteria, and the effluent, which is the water, is treated with aerobic bacteria. And what that does is that breaks down any other microbes that may be present to reduce the volume of the solid waste. So we now have effluent that has been treated, and we also have sewage sludge, which has been treated. So we've got those two parts. And then the last part is that we can use chlorine, UV, or ozone. Now, we haven't mentioned ozone, and ozone is just, it's another chemical that can also be used to sterilize and water and kill microbes. So those are the 5 steps of how to treat sewage. And I'm going to give you a couple of seconds to ask any questions that you have. And then we're going to look at the diagram, and then I'm going to give you a task to do. Does anyone have any questions, guys, about any of these steps? No questions. Okay, right, so let's look at this diagram just so we can put this all in context. Please let me know if this diagram is showing, like, if the zoom has worked as well. It should have. Has the zoom worked on the thing, guys? Yes. Okay. Fantastic. Let me try and make it just a bit bigger. Okay, so the sewage arrives, okay, and then what happens is we undergo screening. Why do we do screening? Type it in, guys. Why do we do screening? What is the purpose of screening? What is the purpose of screening? Good, excellent, okay. To remove large solid objects, to remove the solids, okay. So once that has happened, we then go through to primary sedimentation, okay. And once we have the sedimentation, we have the solid parts, any remaining solid parts going to the bottom, and we call that sludge. So we can see the brown stuff here, it's gone into the sludge, and we've got the effluent at the top, okay? And the effluent goes into treatment with aerobic bacteria, okay? So we have aerobic bacteria, okay? Aerobic bacteria, we go through another sedimentation, so any further sediments will then be sedimented, and we can see there that goes and adds to the sludge as well. And then the remaining effluent is treated with chlorine. O3 is ozone, but you don't really need to know the fact that it's O3 until you come and do A-level chemistry, which I know some of you will do. And UV, so sterilization will happen. And then the effluent is then added to the river, and then it can go on to do what it needs to do in the river. So screening, sedimentation, aerobic digestion of the effluent by bacteria, anaerobic digestion of the sludge, and then the effluent is disinfected or sterilized with either chlorine, ozone, or UV light. Okay, now the sludge itself can also be used. Okay, the sludge can also be used, and the sludge can be used for different things, which you need to know. So as the anaerobic bacteria are digesting and breaking down the sludge, different gases are released, and we call these gases biogas. It's mainly methane, but there are other gases as well, such as carbon dioxide, nitrous oxides as well. And that biogas can be used and burnt to generate electricity. So these plants that carry out this sewage treatment, they actually are quite good with their electricity costs because they're able to use the biogas to generate the electricity needed to do the different parts within the steps to treat the sewage. So it's actually quite a good process because it's kind of a cyclical process that in that it runs itself. Furthermore, the sludge can be dried out and turned into a crusty solid, and that crusty solid in turn can be burnt to generate electricity. So we can see here that this process is quite a sustainable process. And the sludge can also be used for fertilizers in agriculture because it's quite rich in nutrients such as and compounds such as nitrogen, phosphorus, sulfur, etc. So what we've looked at now is the treatment of the reasons why we need to treat wastewater, the steps needed to treat wastewater, and one of the byproducts of the treatment is sludge, and we've looked at the uses of sludge. Does anyone have any questions, yes or no? Because I'm going to give you a task to do. If you do have a question, you can ask it. If you don't have a question, type in no and get a pen and paper ready, because I'm going to give you a task to do to end off this lesson. So if you have a question, write your question. If you don't have a question, you can type in no so that I know, and you can get a pen and paper ready so that we can move on to the last part, the last little section of this. If you do have a question, please just type the question. Okay, right. So what we are going to do now is I am going to show you a diagram, and the diagram has some statements missing, and it's to do with the treatment of wastewater. And I've numbered the steps and or the words describing the steps or the image of something. And what I'd like for you to do is to write the word that is missing, okay? Write the word that is missing. So I'm going to show it to you now. I hope this comes up. Good. So what I'd like for you to do is those words, I would like for you to write what those words are. So what is word number 1, 2, 3, all the way up to 9? So don't write it in the comment box, just write it on your piece of paper. It's kind of blurry. It's not very clear. Is it clear to see, guys? Okay, it's clear. Right, so what you now need to do is you need to write what each word, what each number is describing. So what is step 1, what is 2, 3, all the way to 9? And then we are going to go through that. So don't type it in the comment box. going to give you 45 more seconds to do this. About 10 more seconds. Okay, right. So I'm going to go through this now. Some of them I'm going to ask for you guys to write your word, and some of them I'm going to show. So the first word is sewage. Okay, the first word is sewage. So we get the sewage, and then it goes to step 2. What word is 2, guys? Type in the word for 2 that you got. What is your word for 2? Good. Okay, screening. Okay, so screening happens to remove large particle and debris. Number 3, what is the word for number 3, guys? Type in number 3. Excellent, good. Number 3 is sedimentation. Number 4 is the sludge. So what is number 5? Tell me what number 5 is talking about. So number 4 is the sludge. What is number 5 talking about? Well done, excellent. It's talking about the effluent, okay? And then to the effluent, aerobic bacteria is added, which is with, what is that with? Aerobic bacteria is added, which is with what? If we're talking about aerobic, we're talking about with. Excellent, good. So we're talking about with oxygen, okay? So if we move to the side of the sludge now, the sludge, this isn't there, but what type of bacteria do we add to the sludge? You guys tell me. It's not on this, okay? It's not one of the numbers, but what type of bacteria do we add to the sludge? What type of bacteria do we add to the sludge? So to the effluent, we added aerobic bacteria. Well done, Novella, first person. So to the sludge, we add anaerobic bacteria, okay? Anaerobic bacteria without oxygen. So what is number 7, 8, and 9? Tell me, guys, 7, 8, and 9. What's 7, 8, and 9? Write all of them in the chat. 7, 8, and 9. Okay, so good. People are saying biogas for 7, electricity for 8, but people are saying agriculture for 9. What specifically in agriculture do we use the sludge for? What specifically in agriculture? Excellent, well done. Fertilizers, okay, fertilizers. We use it in fertilizers. So this whole process, you have to know, okay? You have to know this process, and you cannot confuse it with the process for obtaining potable water. If they ask you about potable water, you can't be talking about sludge. And if they ask you about treating wastewater and sewage, you must talk about sludge. You must talk about anaerobic, aerobic effluent. Okay, so we've come to the end of that now. Okay, and oh no, there's one more question. Sorry. What else can be added in the final stages in order to kill any remaining microbes? What else can we add, guys? Tell me. What else can we add in order to kill any remaining microbes in the final stages? Good, well done. Okay, so we can add one of three things. We can add chlorine, UV, or ozone. Well done, excellent. Okay, so we've completed that, which is good. We've recapped our previous learning, topics 14.1 and 14.2, and we have described the process needed to treat wastewater. We've looked at why we treat wastewater, the byproducts of treating wastewater, as well as the process. Well done, excellent. And we did that all within the 1 hour. So what I'm going to do now is I'm going to introduce the topic of the next lesson, and I'm going to tell you what your home learning task is going to be. So the next topic is looking at extracting metals from ores. Okay, now we've already looked at extracting metals when we did in year 9. We looked at things like electrolysis. We looked at using carbon when we looked at the reactivity series. But we're going to look at different methods. But one question I want to ask, what is an ore? I want your definitions. Cast your minds way back to, we did this around February 2019, last year. What is an ore? O-R-E, what is an ore? Think. What is an ore? What is an ore? Yasin Jamal. Okay, right. So, an ore, according to AQA and not according to Wikipedia, okay, is a rock which contains enough metal which is worth extracting. So that is a that is a warning. It might even be a straight relocation if he's not careful. So a rock which contains enough metal which is worth extracting is an ore. Okay, is an ore. So what I would like for you to do is a home learning assignment. So once this lesson has once this is over, I'm going to upload into the groups a fact sheet, okay, about this lesson 14.4, and you can either print it or you can write it in notes in your book. I'm sure most of you would rather write it up. I know you do all your colors, your underlining, your different things like that. So it's going to be a fact sheet and you can write it into your book. You can look at this on Seneca as well, okay, but this fact sheet contains like flow diagrams, different things like that I'd like for you to look at. Seneca learning is good to supplement it as well. I'll set something on Seneca as well, as we do every week, sorry, but I also want for you to look at this fact sheet. And your task is going to be to read the notes and make sure you understand it. And we're going to have 2 sessions next week. We're going to have a session on Wednesday and a session on Friday. But the Wednesday session is going to be a shorter session, and it's going to be for any questions from that task, which is to make notes from the fact sheet into your book. And I'm also going to give exam questions on topics 14.1 to 14.4 that also should be completed. So first thing is the fact sheet. Make the notes in your book. You can either print it out and put it straight into your book, or you can write it up into your book. Make sure you understand it. That's the second thing, that you understand it wholly. And then the third is on Wednesday, it's going to be a short session. It's going to be like a question and answer. Any questions that you have about 14.4, ask me, and then if you don't have any questions, or you've asked me your questions, you are then able to answer the exam questions, which is going to be on chapters 14.1 to 14.4. So that is it for today. We've just clocked an hour already, which is fantastic. So that is it for today. If you have any questions, okay.